In 5a, we are multiplying two complex numbers. So when we multiply complex numbers, we just have to keep in mind the fact that I squared is equal to minus 1. All right, this comes from the fact that I is equal to the square root of minus 1, and when we square both sides, we get I squared is equal to minus 1. So let's just keep that in mind. All right, and we start multiplying complex numbers using the FOIL order of multiplication, first times first. Okay, so that would be 3 times 2 is 6. And now the outer would be 3 times minus 5i. That's minus 15i. Now the inner term is 2i times 2. That's plus 4i. Now the last times the last, that's where the I squared equal minus 1 always comes in. Last times last, we have 2 times minus 5, that's minus 10. Then I times I is minus 1. So that's a plus 10 over there. So let's now combine like terms. Let's just indicate over here that we have this is a plus 10. All right, so we have 6 plus 10, that's 16. And we have minus 15 plus 4, that's minus 11i. In 5b, we're dividing two complex numbers, and the way we do that is we multiply top and bottom by the conjugate of the denominator. So that would be the same number with opposite sign in the middle. All right, so that would be 1 minus I in this case. Okay, first let's do the numerator, and we'll multiply using FOIL. So it's 3 times 1 is 3. Then here for the outer we have minus 3i. For the inner we have plus 2i. And for the last we have 2i times minus I. So that's minus 2. And I times I is minus 1. So that'll be a plus 2 over there. Now in the denominator we're multiplying complex conjugates. So let me just remind you how that works when you multiply complex conjugates using FOIL. The middle terms drop out and we just get the first is a squared. And for the last we have minus b squared times I is minus 1. So that turns into plus b squared, a squared plus b squared. All right, so in this case, a is 1 and b is 1. So a squared plus b squared, that's 1 plus 1. So we have 2 in the denominator. All right, and this is a plus 2 over here. So let's simplify the numerator. We have 3 plus 2. We have 5. Minus 3i plus 2i, that's minus I over 2. All right, so you could write the answer like that, or if we just split this up, we have 5 over 2 minus 1/2 I. In 6a, we have a rational equation, and we're going to solve this by clearing out the denominators. So we'll multiply both sides by the common denominator, that is by x plus 4 times x minus 2. All right, so let's do that. On both sides, and here as well. Okay, on the left-hand side, these cancel, the x plus 4 and the x plus 4. So on the left side, we have 5 times x minus 2. Okay, now on the right side, I'm going to multiply through and then do the canceling. Okay, that's this product times 4 plus 3 over x minus 2 times x plus 4, x minus 2. Okay, now these cancel, the x minus 2 and the x minus 2. All right, so let's start simplifying. On the left, we have 5x minus 10. Multiplying through, that's 5x minus 10 is equal to. Now on the right side, we have to multiply out x plus 4 times x minus 2. Okay, we're going to get a quadratic, so that's x squared. And then we have minus 2x plus 4x. That's a plus 2x combined. Minus 8. 4 times minus 2, minus 8. And here we have 3 times x plus 4. Alright, so let's just multiply through by 4 in the first set of parentheses, so that'll be 4x squared plus 4 times 2, that's 8x, minus 4 times 8, that's 32, plus 3x plus 3 times 4, that's 12. Okay, on the right-hand side, we can do some combining of like terms. Okay, here we have an 8x and a 3x, that's 11x. And here we have a minus 32 and a plus 12, that's negative 20. Alright, on the left-hand side, let me just copy over that 5x minus 10. So we have a quadratic, we want to put it in standard form. In other words, 0 on one side. So let's say we will start by subtracting 5x from both sides, and we'll add 10 to both sides. So start by minus 5x on both sides. So that's 4x squared. Then we have 11x minus 5x. That's plus 6x. Okay, I'm going to add 10 to both sides at the same time. All right, so I have minus 20 plus 10. That gives me a minus 10. All right, so here we have a quadratic in standard form, and we want to factor that. The coefficients are a little big, but notice we can factor out a 2 from all the coefficients. So let's do that first. So here we have 2x squared plus 3x minus 5. All right, so that's a little bit easier to factor. So let's do that. Okay, here we have, let's do 2 sets of parentheses here. 2x squared, we'll break that up as 2x times x. And now we want a minus 5, and we're going to have different signs here. All right, we want to get a plus 3x in the middle. Okay, so let's say we put a 5 here and a 1 here. All right, a plus 5 and a minus 1, so that's 5x for the middle term. Let's check that we get a 3x. So we have 5x minus 2x is 3x. So we check the middle term. And then we just set each factor equal to 0. Okay, and solve. 2x plus 5 equal to 0. X minus 1 equal to 0. Okay, so here we have 2x is equal to minus 5. Oops. And x is equal to minus 5 over 2. And here we have x is equal to 1. All right, now let's go back and look at the original equation to see which solutions we would have to reject. If we had x equal minus 4 or x equal 2, those correspond to values that make denominators 0. X equal minus 4, x equal 2. Okay, but we don't have these here, so these are valid solutions. Six B is another rational equation, and we'll clear out the denominators by multiplying by the common denominator. The common denominator is x plus 5 times x minus 2. So we'll multiply on both sides by that common denominator. Okay, on the left and on the right as well. Okay, here we don't have much room. Let me just write x plus 5 times x minus 2. Okay, on the left-hand side, x minus 2 cancels in the numerator and denominator, so we're left with x plus 5 times 4. On the right-hand side, we'll multiply through, and then we'll do our canceling. So we have minus 3 over x plus 5 times x plus 5x minus 2. And then we have 7 over x plus 5x minus 2 times x plus 5x minus 2. All right, let's start canceling now. This x plus 5 in the denominator cancels with this. And here, x plus 5x minus 2 cancels with x plus 5x minus 2. All right, let's multiply through. On the left-hand side, we have 4x plus 5 times 4, 4x plus 20 is equal to, and here we have minus 3 times x minus 2 plus 7. All right, let's just simplify this. Notice this time we're not going to get a quadratic. This time we're getting a linear equation, no x squared term here. So we don't have to set to 0 and factor. We're getting a linear. So here we have minus 3x plus 6 plus 7. So that's 4x plus 20. Just combine on the right-hand side, just combine the 6 and the 7. That's minus 3x plus 13. And now we'll solve in the usual way. Let's add 3x to both sides. So we have 7x. And subtract 20 from both sides. 7x is equal to 13 minus 20. That's minus 7. Divide both sides by 7, and we have x is equal to minus 1. Now notice that minus 1 is not a 0 of any of these denominators. Okay. So minus 1 is a valid solution. In 7a, we have a radical equation. And the basic strategy for radical equations is isolate the radical and square both sides. All right, so we're going to isolate this radical by adding 2 to both sides. So here we have 3x minus 2 is equal to 7. All right, so now the radical is by itself on the left side of the equation, and we're ready to square both sides. All right, so let's do that. Okay, so we're squaring both sides, and then on the left side, the square root sign pops off. We just get what's inside. We get 3x minus 2. On the right side, we have 49. Now notice whenever we square both sides, we must check solution. Okay, that always happens when we do this. When we square both sides, we must check the solution later on. All right, so let's get our solution. So add 2 to both sides, and we have 3x is equal to 51. And let's divide by 3. And we have x is equal to 17. Okay, so here's our check now. We have the square root, check back into the original. 3 times 17 minus 2. Okay, now subtract 2. Is that equal to 5? All right, that's 51 minus 2. That's the square root of 49. And that's 7 minus 2, which is equal to 5. So this is x equals 17 is a valid solution. 7b is another radical equation. So we'll start by isolating a radical and squaring both sides. Because we have 2 radicals in 7b, we anticipate having to square both sides twice. Okay, but we'll start by isolating this first radical. So let's write the square root of x plus 1 on the left. Now I'm adding square root of x to both sides is equal to the square root of x plus 2. All right, and now we're ready to square both sides. Let's do that. On the left side, the radical pops off. We just get x plus 1. On the right side, let's write this out. We're multiplying square root of x plus 2 times square root x plus 2. So we're just going to FOIL this. So here first we have square root x, that's x. In the middle we have 2 root x plus 2 root x, that's plus 4 root x. And then 2 times 2, that's plus 4. Alright, now we're going to isolate this radical and square both sides again. So let's start by subtracting x from both sides. Minus x. So these cancel each other out. Alright, let's subtract 4 from both sides. So we have 1 minus 4. That's minus 3 on the right. And on the left, we're left with 4 times the square root of x. And now we square both sides. Okay, so then we have 9 is equal to 4 times 4, that's 16. Root x times root x is x. And we have x is equal to 9 over 16. Now, since we squared both sides, we must check. Alright, so we always, radical equations, we always check our solution. Okay, at least, okay, square root equations. So let's do that. So let's substitute back into the original. Okay, so we have the square root 9 over 16 plus 1 minus the square root 9 over 16. Is that equal to 2? That's substituting back into the original. Let me just remind you, here's the original. Okay. Alright, so there we substituted in. Okay, so what do we get here? We have to add these two terms together. I'll write 1 is 16 over 16. Okay, so there we get square root of 25 over 16 minus the square root of 9 over 16, and is that equal to 2? So here we have 5 over 4, and here we're subtracting, taking the square root top and bottom, 3 over 4. We have 2 over 4, and that's not equal to 2. So that tells us that x equal 9 over 16 is not a valid solution. So that means we have no solution in this case. Alright, now that's not surprising because look back at this step. We had a radical equal to a negative number. So we could anticipate that this would lead to no solution.